let's get going. It is week 16, day 2. We could keep up with the threads because there was a little bit more I want to do on that. Huffman coding is kind of a complicated assignment. I'm just going to give full points to anybody who passed at least 6 of them, so it seems good enough to me due to the weird inconsistencies in how the thing was grading, undefined behavior and all that. So yeah, hopefully you guys can see kind of how messy things can get when life gets complicated. All right, so what are we going to do for our final project? Well, we are going to do a networked quiz show. Let's see. In Java. All right, so let's pull that up. Clear the screen, get the grades off there. Huffman's been graded, so if you didn't get it working, I don't know. If you haven't used your last chance yet, seems like a good time to use your last chance. It's 20 points. So. All right, so let's see. Sockets. Boost. Yeah, we'll probably talk about that today. I guess first we can talk about threads again. So the most common way that we do threading, well, okay. So there's 2 main uses for threading. One is when you want to do some sort of asynchronous computation, right? Like something that handles keyboard and mouse input, and you don't want your regular main to have to worry about it. So like when the user types something, they click something, then the thread handles it, and your main program will just check to see, you know, what values things have. That's pretty common. It's pretty common to split off a thread for I/O kinds of things, networking, for example. So main will just toss things into an output buffer, and then a separate thread will pick up the data from the output buffer and push it out over the network and read from the network and put everything's in the right place, and main just doesn't have to worry about it. It just accesses some data structure and there's all the stuff. Or AI could run in a separate thread, and then it just runs periodically and goes to sleep, and then runs periodically and goes to sleep. That's pretty common as well. When I did high performance computing, a lot of when we would parallelize an algorithm, parallelizing means you have multiple programs or threads running at the same time on the same problem. Then the most common thing we would do is have a giant array, and we'd chunk up the array and then pass out a chunk to each of the threads. And so if you had a 10 CPU system, a 20 CPU system, each CPU would get a 20th of the work, and then when they all finish, it would terminate, and you'd get hopefully 20 times the performance. Realistically, not, right? Because there's always overhead to these kinds of things. So any 6 extra credit to those who pass more than 6? Can you get some extra credit passing them all? Sure, why not? Okay. All right. Why not? That was a lot of work. All right. Why is my thing not? There we go. So let's give an example of that. Let's do a thing. Yeah, I've already got most of this set up. Okay. So yeah, so that's lambda. So that just makes a function with no name. The square thing here is used for lambda capture. If you want to bring any variables inside of it, like size or something like that, then you can pull in a variable and use it inside of here. But I don't need it for here. So this is going to dump the whole array. We don't need you. So what are we going to do? So we're going to, how many threads do we want? How many big an array do we want? Okay. some shared counter, delete the array. Okay. So what we're going to do is we are going to spawn a bunch of threads, which, did I delete the thread? Call the thread? Okay, I guess I did. Thread constant threads. So we're going to make an array of threads, delete threads. Every new needs a delete. We'll build a wall that separates from the non-stem natures. That's fine. All right. So we're going to make an array of threads, and each one of these threads is going to be given a chunk of the problem to work on. All right. So first of all, let's do a single-threaded count. First, sum up the array in single-threaded mode, and so we can say long. What are you doing? You went 64t. Sum equals accumulate from array to array plus size, starting with 0. Accumulate's a weird function. Honestly, it should default to 0. That's used, like if you put in 100, the answer would be 100 plus whatever the sum of the arrays. They do that for doing subtotals and things like that, so you can pass in the result of a previous accumulate into the third parameter there. I think it ought to just default to 0 if you don't pass one, but there you go. So there's accumulate. And maybe we'll cut this out here, and just to verify. Numeric. It's in the algorithm library, but you have to hashtag include numeric. Because of course you do. All right. Warning, comparison of integer expressions, different signedness. How many threads? 10, a big array, 10. Okay, so big array 4. All right, 160, 250, 263, 268. 230, 240, 252, 258, 261. Yeah, okay. It'd be cool if G++ knew about every standard library function. It will suggest them sometimes. It's kind of odd that it doesn't. Okay. Yeah, okay, so our accumulate function is working right, and we can time it by, you guys want to use the C world way of doing it, or do you want to use the C++ way of benchmarking something? C++ way, all right. So that means we have to copy and paste code. Let's see. Nope, that's a C way. It's fine. if you reference it. Again, the benefit of doing things the C way is that you don't actually have to Google things every time. So use chrono. Chrono is nice, but it is not. It is so verbose. It's annoying. Let's see, chrono. And what we want is steady clock. High resolution clock. Oftentimes is the same as steady clock. We'll do steady clock. It can't run backwards. That's what we want usually. And we get now. It's a current time. So stood : chrono : time point. Angle bracket stood : chrono stolen steady clock. Yeah. Good job, standard library designers. That's memorable. All right, so copy and paste code like a pro. Equals, by the way, will indent, like if your indentation is screwed up. Equals, indent, reformats the current line you're on. And then we'll do end. So we'll get the starting time, the ending time. We'll see out single threaded benchmark time. And then we do a difference between the end and the start. And we can actually do this all in one line, but okay, oops. Now the C-world way of doing this would be int clock, int start equals clock, int end equals clock, cout end minus start, and that'll give you the number of ticks. It's way easier to remember. So there you go. This is the C++. That's how you start a timer. Start a stopwatch, really. It's not really a timer. Okay. On your C line, you made an include file that has all the includes you've learned so far, so I just include that in your code. I mean, if you're going to do that, then you might as well just include bits. So single-threaded benchmark time, 1.9 times 10 to the negative 7th power. So if you include this, that gives you all of the standard library headers. But it's going to, it'll slow down your compilation time. So, all right. So single-threaded benchmark time, pretty fast. Right? And since we're confident this is working correctly, all right. Single-threaded sum. So I'll put the sum, we'll output the time it took, and then we're going to do the same for the... We'll do the same for multi-threaded. So for multi-threaded, what we're going to do is we are going to run this multiple times. Each thread will get a pointer to the array, and then it will get an index that it's going to start at and an index it's going to end at. So if you have an array of size 100, you've got 20 threads. The first thread gets the first 5, next 5, next 5, next 5. You guys understand? So, all right. Does accumulate take actually? Does it have the parallel version? That's a good question. C++20, they're trying to add parallel stuff into the standard library itself. No, not yet, I guess. I think it's in a TS still. Experimental parallel, yeah. Heck, let's try that. Doesn't exist? Okay. No. That answers that question. All right. I tried that bits in Vim. It didn't compile. Yeah, it'll work fine. It works fine. Okay. That's new concept. All right. Actually. It is set to C++20. Yeah. Oh, all right. So let's go back in here. Yeah, the future though is you'll be able to use a parallel accumulate, and then C++ will figure out the fastest way of accumulating an array for you. You don't need to worry about doing it manually, kind of like what we're doing here. Okay, so we're going to do a for loop. Okay. So. So for every thread that we have, we are going to make a thread and run, probably need some variables here, int, I've already used the word start, int x, start, my start, thread start, index start, it's going to be equal to 0, and index end is equal to how much work do we have? So the amount of work we have is size divided by threads, and we should probably do some sanity checking there to make sure none of these numbers are 0, for example. But it's okay. It's just demo code right now. So we're going to start it. So for the first thread, it's going to go from 0. So let's say we have 100 elements in the array. Then we're going to pass in, and there's 20 threads. So that means we're going to pass in 0, and we're going to pass in 5. And we're not going to do element 5. 5 is actually going to be at the beginning of the next one. So yeah, because we go less than end. Right, this is the half open pattern we always use in computer science, where we start at start and we go up to but not including the end. So like in algebra, we'd say like from 0 to 5. Like that, right? So that means including 0 but not including 5. And the reason why we use the half open pattern is because it makes everything a lot easier, it turns out. So you don't have to start adding 1 and subtracting 1 off things in most cases. Start using if statements and loops on one line if they have one argument. Yeah. It's whatever looks nice to you. So this is, now we sum it up in multi-threaded mode. So we're going to start at 0. The end will be 5 if size is 100 and threads are 20. Does that make sense to you guys? Do you guys kind of understand what I'm getting at? Like we're going to split up an array and pass out different chunks of the array to different threads. Is that? You guys kind of get what's going on here? Okay. So threads, square bracket. I is equal to thread passing in our function array sum. So this thread is going to, let's see, take array sum, and it's going to go from index start to index end. Then we say index start is equal to index end. So the next thread will start on the where the previous one ended, right? So index start for the next thread will start at 5, and index end needs to move up to 10. So index end plus equals size divided by threads. And you might be like, should we optimize that away? I don't know. Maybe we could. The optimizer will handle it for us, but maybe we could. Const. Might as well make you a size also. Const work. How big the array is divided by how many threads we have. Okay, so that'll spawn off a bunch of threads. Each thread then knows which part of the array it is responsible for. If the thing doesn't divide evenly, then we're not going to get a good result because the last thread needs to pick up whatever remainder there is, right? So rather than that, let's see here. If I is equal to threads minus 1. We'll do something different. So if we're on the very last thread, then the end will be size. Right, because if we have 103, then the last element, the last thread needs to do 8. So if we're on the very last thread, it'll just go to the end of the array instead of where we think the end of the array is. Does this still have to do with sockets or multi-threading? A different topic. They're related. That's why I'm talking about them together. So when you're going to be doing a multi-threaded thing in Java, each client handler on the server will be in a different thread. Okay. So you have to kind of get used to multi-threaded stuff for this reason. And plus, this is also just good for you to know stuff as well. So G++ thread.cc -pthread thread. What the error? I don't know. My face is blocking it. Let's turn my face off. Oh, my face isn't. Oh, okay. All right, here we go. All right. Must be invocable. Thread arguments must be invocable after conversion to R values. Let's see here. Callable equals void. Taking in 2 long unsigned ints. Might be a matter of these things not being the right type. Let's see. Long unsigned ints. Instead, when I'm passing in size t. Oh, I'm not passing in the array. Okay, that's why. So I have to pass an R. There we go. see if that works. There we go. I want to spawn 20 threads and an array of size 100, and it core dumped. Cool. It's because I didn't join. Okay, right. So we're gonna do that, and then after that, we're gonna join them all together. For every thread, we are going to call threads I join. So it's going to wait for everybody to finish. And it's possible we're running out of bounds too, but let's see how it goes. So, 20 threads, 100 array. Okay, so it worked. Of course it worked. Why wouldn't it work? Okay. So now we just need to benchmark it. I should not make this a double. Let's make this like a int or something. So doesn't like int? Fine. Double, I guess is fine. Okay, so and then we're gonna output you. Multi-threaded sum and multi-threaded benchmark time. How many threads? 20. How big's the array? 1,000. So you can see that the multi-threaded code is substantially slower than single-threaded, which is normal for small amounts. And on our server, it's probably going to be, you're probably not going to get much benefit out of more than 2 threads anyway. Yeah, here you can see it's still slower. And this is because the server isn't very parallel, right? I think it might actually just be a single core, just based on my experience trying to parallelize it. It appears to have 2 cores, but I don't know. Let's do 100,000, million, 100 million. Single-threaded sum. Yeah, you see, even with 2 threads running, like you get the exact same performance as 1 core. So, they're giving different answers. Overflow, probably. Let's see here. Sum. I think accumulate's probably overflowing. Thousand, 10,000, 100,000, million, 100 million. There we go. Yeah. And so this is another reason why I don't like the design of accumulate. Accumulate takes a third parameter that is the starting value to add to, which should be 0. But if you pass in a 0, zeros are ints. And so accumulate's actually a templated function. And so it derives what template parameter it should be from the third parameter. So it says I'm going to be doing integer addition. And so by doing it this way, it was actually using integers internally, and it was overflowing. And so I passed in a long here. So I changed it from 0, which is an int, to a 0 long, and then it worked properly. And so that's a very subtle bug that you can get from accumulate. And in reality, what I would like is this, right? I would like to just not pass anything in and have it deduce the type from the left-hand side, which is what my read library does. My read library is templated. Like I can say, read an int if you want, but it can deduce what type it needs to be from the left-hand side. and accumulate can't. And so when you look at source code for accumulate online, you just put in a 0 there, right? It's what everyone puts in. And then you test it. You test it and it works fine for small numbers, but then when you get to big numbers, it doesn't work. And so you have to change it to a 0 long long. Or let's see if this would work. Accumulate angle bracket unsigned integer 64t. Let's see if that would handle it. Nope, it doesn't like it because that's an int. Okay, so yeah, it's a unsigned long long. So there are different suffixes you can put on numbers. So for example, if you wanted to have 100 be a floating point number, you put an F there. And then now you're doing modulus with a float, which won't work. You can put a string, you can make that a string. And then modulus really doesn't want to do anything with a string. No, that's chronoseconds, sorry. That's, those are seconds. 100 unsigned would be a U. So there's all sorts of these weird suffixes you can use in C++ to indicate the type of a literal. So a literal is a number that appears directly within your code, like this. And so there's a whole bunch of these. The ones you've probably seen me use a lot is like auto s equals hello world. So like if you do it this way, what type is s? Do you guys remember? Auto deduces the type from the right hand side here. We've gone over this before in class. What is the type of the string literal here? Double quote hello world double quote. What type is auto going to deduce? Nope, it is not a string. This is the same thing as if you had written const char star s. Okay. And that's one of the reasons why I'm not a fan of auto, is because there are some things in C++ where you think you know what the type is and you're wrong. So if you want to make this a string class, you put an s after the closed double quote. So this will now be a string instead of a const char star. So there are all sorts of literals. Let's see here. You can use. Let's see if we can find a list of them somewhere. 213. If you put a prefix of a 0, it becomes octal. If you put a prefix of 0x, it becomes hexadecimal. 0b makes it a binary number. Put an LL there, it becomes a long long. If you put a ULL, which is what I had right there, it's an unsigned long long. Put a U there, it's an unsigned. And then they don't have the other suffixes. Okay. Unsigned integer, long integer, unsigned long integer, long long, unsigned long long, float, double, or a long double rather. And then prefixes can include Unicode, right? And so these are a bunch of different things you can do there. And let's see, L is wide char, const star, char 16, go away. And so they have different prefixes for doing Unicode, strings, and unsigned, long, that kind of stuff. So there's different prefixes and suffixes that you can put on things. GCC has non-standard extensions. That's cool. Okay. So, does 45 or 26 or 50b review or expand on threading? No, not at all. Parallel processing is a junior level topic, but we finished this semester 2 weeks early, so you guys get to learn some actual very valuable stuff. I've been talking with the Bridges people, and they think that multi-threading and parallel processing should be taught earlier in the curriculum, because right now, like I said, it's a junior level topic, and they think it should be introduced as either like OpenMP, where I said you can just do a hashtag, pragma OMP parallelize for, and it'll just parallelize for you, or threading in second semester. So we're all done with the semester topics already. Yeah, we finished last week, dude. So you're in bonus hours, because there's normally midterms, right? And normally the midterms take up a few days. Preview the midterm, take the midterm, review the midterm. So you guys got 2 extra weeks of topics. Okay, so so this is. Do you guys kind of understand what's going on here? Like, I'm basically taking a giant array, I'm chopping it up into bits, and handing out a different part of the array to each of the different threads. So this thread is created, it's going to run that function, getting these 3 parameters passed in. And the parameters are the array, where you should start, where you should end. And then it's going to add up everything inside of there, and it's doing the atomic. It's doing an atomic add, so I don't need to use a mutex. And so all of them are going to do an atomic add plus equals, basically, to the shared counter when they're done. And then at the end, we just print out whatever values in the shared counter. And that's it. So this is the equivalent of doing an accumulate. Can I ask for a suggestion to introduce us to Python? Yeah, that'll be an extra credit assignment. So there will be an extra credit assignment due the end of finals week, and that will teach you Python. It's pretty easy. It was made by NASA. I did it last semester with CSI 26. They did fine. My CSI 1 students had harder time with it, in part because in order to do it, you have to download Visual Studio Code and get a development environment set up, and that was a little tough for the CSI 1 students. How many more assignments do you have? You have 1 more assignment, and then the extra credit as well. And there's no final or anything during finals week. There will be another competency exam reviewing all of these final topics, so you can't get away from not knowing them. There will be a CSI 41 cumulative competency exam, and then there'll be retakes on the competency exams, and that's it for the semester. Okay, so let's get back into the sockets side of things. But what I wanted to do here is actually show you what like a real threaded program will look like. I wonder if we can. Let me try something here. I don't know if I have it actually set up on my local machine here. Let's see, view. Let's see, text document. All right, we'll call this thread CC. So I got here Visual Studio Code, and I'm just going to copy paste this over here, and we'll see if we can actually run this on a real machine, so to speak. There we go. All right. Include Unix standard. Oh, it's not going to have the read library, is it? You don't exist, so we're going to have to do it the slow way. Okay. Int x equals 0. See out how many threads. Cn into x same for you. That should work. All right. So let's see if I have the compiler installed on here. Python. Why is it just launching this? No. Just opening up a JSON file. Fine. Let's open in Visual Studio. Do the real one. Will Seaside 26 be the same way as this 41? I don't know. I haven't decided yet. Maybe. New version of Night Visual Studio is available. Okay. Still opening. Run. Yeah, whatever. I don't have time to deal with this. All right. We're going to keep the video lectures on YouTube. Yeah, my runtime on Windows isn't set up right, so I'd have to configure it. I'm not going to waste time on it. It's already 12:50. Currently, the thinking is they're going to be online, whether or not they're in person. I don't know. We'll see. It's too hard to say right now. Okay. So anyway, in theory, if you guys click this here, I'll just put up copy thread.cc up into public and make it visible. If any of you guys want to download that onto your machines and try running it and see what kind of performance you get on your machine, because there's kind of no point doing it on the server, because I think it's actually only one physical core, 2 logical cores. Tell me what kind of performance you get. Okay, so let's get into sockets again. So Echo Server. Is the MQ installed here? Great. Yeah, doesn't matter. We're doing Java anyway. Okay, so sockets boost. Okay, so somewhere I had on here. Java knock server. Server side of a socket. Okay. So what your next homework assignment is going to be is you're going to make a quiz show that's networked. Okay. So you're going to have the ability for multiple people to connect to a server you make. and the person has to type in their name, Bill, Genghis Khan, whatever. And then when there's, let's say, 4 people connected, then the server will send out a question to people. When was Taylor Swift born? Whatever. That was what Josh Gomez did when he did this project a few years ago. He made a Taylor Swift trivia server. And so basically, what you're going to do is just run people through a series of questions. The users will type in A, B, C, or D, 1, 2, 3, 4, however you want to do it. And they'll send a string to the server. The server will be like correct or incorrect. It'll keep track of the scores. And then after 10 questions or whatever, you say, congratulations, Muia is the #1 Taylor Swift fan of all time. That's it. Okay. Extra credit will be available if you go above and beyond. And otherwise, just do the minimum, I guess. It's up to you. So you'll do this in partners as well. So you can keep your same groups as last time or not. It's up to you. So the knock server. Let's see where we got. All right. Download the sample. Thank you. Select all. Copy. Thank you. We are never. Yeah, give me a copyright strike, huh? Because I sound just like Taylor Swift. All right. Okay, sorry. So Vim, what is this called? Knock server.java. Okay, this is not the multi-server one. Actually, I think we might need that. Let's keep that around. Okay. Knock client, knock protocol. Down to the sample. Client. And then we will need the multi-server. Yeah, we'll do that next. Let's just see if we can get this working. So if we Java C knock dot star, really knock star, that'll compile all of them, so I don't have to type 3 of them. And then I can run knock. Let's see, Java knock server. It's going to ask me for a port number. I'm going to run on port 9000. Create a new window. Then I will run Java knock client, which will be connected to localhost and port 9000. Server knock. Who's there? Turn up who? Turn up the heat. It's cold in here. Want another? Sure. Knock. Who's there? Little old lady. Little old lady. Who? I didn't know you could. Little old lady who? Oh, that's absolutely terrible. No, and then it quits. Okay. So I can push this out to you guys, but let's do the multi-threaded one, because this is going to be your starting point. Your starting point is going to be the multi-server and multi-server thread. So let's go ahead and get this here. Copy. I thought I had all these downloaded. Wait, knock. Oh. Yeah. Vim KK multi-server Java. It's perhaps a little bit unfortunately named, but all right. Copy. There. And KK multi-server thread. KK multi-server thread. Okay, so let's see, Javac, KK multi-star. Okay, so if I run Java KK multi-server on port 9000, then when I connect, make an AI that can tell knock-knock jokes that flow. That'd be a cool project. It'd be a good summer project. All right, so we are going to run Java KK. Let's see, what was it? Knock client on localhost port 9000. Knock knock. Who's there? Who's there? Turn up. Do you want another? No. Notice the thing doesn't quit. All right. We did it last time. So the KK multi-server. Is pretty simple. All right. So if you run it without passing any command line, what's with the formatting? GG equals capital G. Okay. So if you run without any command line parameters, then it tells you. Remember, you have to run it with a port number on it. It parses the first command line parameter here to get which port number, like turns string 9000 into the number 9000. It tries, remember, try and catch, right? Same thing in C++. So if a IO exception occurs, then, for example, if you try running the server twice, it'll throw an exception on the same port, that is. It'll throw an exception. So it tries creating new server socket, and that basically is going to just be opening up a socket. Hey, I'm on port 9000. Anyone can connect to me. And then while true, essentially, it's going to, every time somebody connects to the server, it will accept, waits for somebody to connect. It blocks until somebody connects. Somebody connects to the server, then it will pass that socket to this guy here that we'll take a look at in a second, and calls start on the thread. So in Java, a thread doesn't run until you call start on it. All right, in C++, you pass it a function and it runs that function immediately. In Java, when you make a thread, this is a small difference in Java. Dot start starts thread. Okay. And that's it. That's the entire server. So all it does is every time somebody connects, it spawns off a new thread. Say you handle them. You talk to them. Okay. And that would be that. If you want to have shared data, you'd probably need to create like a scoreboard here inside of the multi-server, and then pass that to the server thread. Let's take a look at the server thread. Like this. And so it extends thread. It gets past the socket, and it sets its socket to socket. It's doing the present state way of initializing. this dot socket equals socket. In C++, of course, this would be this arrow socket. That way you don't have to come up with a new variable name, I guess. Public void run. And so when the run function gets called, then it grabs the socket's output stream to write to. It grabs its input stream to read to. It decorates it with some buffering and things like that. And basically then you can write to out and read from in. And you can read from it like you're reading from the keyboard. You can write to it like you're writing to the network. It's really, really nice, really easy. And it's actually much easier to do this in Java than it is in C++, trust me. It creates a new knock-knock protocol, which is the, it's in a different file. It grabs, let's see, string, prints it to the socket, and then as long as the user keeps typing things, let's see here, output line, prints the output line. Let's see, it reads something from the user. As long as the user is still typing things, if the user disconnects, it'll return null, and then you close the socket, right? When the user types null, kills the socket. If the output line equals by, which is what you say, so this is the knock-knock protocol. That's the thing that's doing the to and from. That's doing the actual meat of the assignment. If it ever returns by, which is what you type, if the user types nope, I don't want any more knock-knock jokes, it prints by to the user, and then it checks to see did I just send by to the user? If so, quit, and then it closes the socket, and that's it. So that is a multi-threaded server, and all the actual meat of it is being done inside of the knock-knock protocol, where it's actually doing the reading and the writing to, it's actually doing the knock-knock stuff. This is Fresno State. You got admitted to Fresno State. Congrats. So do you guys kind of follow this? Because you're gonna have to do this. This is your next homework assignment. So I'm gonna give you all the source code. So it's your job to turn a knock-knock joke server into a quiz server. Oh. You guys think you can do that? Let's look at the knock-knock protocol.
Hey, I was about to start working on the extra credit thing. Can you real quick send me the imaginary homework again? I accidentally... Oh wait, no, it's still in that same folder. Never mind.
Okay, so basically, these are consts, right? Remember that public static final, or in this case, they're private static final. These are consts, and so it's like an enum basically. They've got a few different states that you can be in. So basically, when you're talking to the client, when they first connect, it's in the waiting state, so you send to them knock knock, right? And you change your state. It's a state machine. We talked about this in CSI 40 a little bit. State machines where you have a variable keeping track of what state you're in, and when you're in a state, you can transition to another state. In this case, it's pretty simple. You output something to the client, say knock knock, and then you move into the I have sent a knock knock state. And then when you get input from them, you check to see what state you're in. If you're in the sent knock knock state, you check to see if they wrote who's there. If they did it properly, then you move on to the next state. If they typed it in improperly, then it will say you're supposed to say who's there, try again, and it doesn't change the state. You see that? So if I were to run it again and not type in who's there, it'll be like, oh, you're not following the knock knock, dude. But once they type who's there, then it grabs a clue, turnip, little lady, whatever. It starts off on current joke 0, and if you ask for another joke, the joke goes up by 1. So it first does the turnip joke, then the little lady joke, so on and so forth. So it's keeping track of which joke they're on. And what you can do if you want to have shared variables, you can just pass a variable to the string and to the thread, and then all the threads can, talk to each other. Well, you can pass on like a scoreboard that has a list of who's connected to the server and what their score is, and then at the end of the game, after everybody goes through it, then you print out who won to each person. It's pretty straightforward. Okay. Okay. So if they type in who's there, then it moves on to the next state. The next time they write something back, you've sent them turnip, and then it's checking to see, did they type in correctly turnip who? If you did, then it will give the answer. Turn up the heat, it's cold in here. Do you want another? If you don't, then it prompts you to it actually starts over. So if you give the wrong turnip who response, then it actually says try again, knock knock, and it sends you all the way back to the first state where you have to say turnip who's there. So this is a state machine. So state machine is, you just have a variable holding your state, and when something happens, you transition to a different state, or you stay in the same state, or you go backwards a state, or something like that. And this is how you program gas pumps and things like that. So if they say turnip who, then it prints out the answer, followed by want another. It moves to the other state, another state, in which case it will, if they type yes, then it will do knock knock again. It moves up one joke at a time. If you hit the cap of the jokes, then it goes back to the first joke again, so it can do infinite jokes. If you hit no, it outputs by, and that's it. And then whatever string you chose, that gets returned. And then the server checks to see if you send out by. If you send it by, oh, actually, that's probably wrong. I think it's by with a dot, right? It's a by there, and it's a by with a dot here. I think it's a bug. I think they have a bug in their code. Yeah, see here it's checking for by with a period, but I think the multi-threaded one's actually wrong. I think this should be that. Which I think would actually, I think the reason why it's actually working is because it sends that to the client, and the client disconnects, because the client disconnects at that point, and then it reads a null, and then it goes on anyway. But that's a bug, pretty sure. So once it sends by to the user, now it should disconnect them. It closes the socket. It's just like C++, right? You can open a file for reading. When you're done with it, you can close it. If you don't close it, then whenever it goes out of scope, it'll go away. In this case, it's a class variable, so yeah, you probably want to close it. And that's a multi-user server networked. It's not bad. It's really not bad. How many knock knock files? You're not making knock knock. You're not making knock knock. You're making a quiz game. Okay. In the junior level class, is this threading concepts and pure algorithms, OSDB, or advanced Java? Okay, so yeah, I guess we have 20 minutes left. Let's talk about your future in computer science. So 40 and 41 are the learn to program classes. So in 40, you learn the basics of for loops and if statements and things like that. And 41, you learn the importance of data structures. And I hope you guys all understand how bloody important data structures are now. Like what a massive difference in performance they make if you use a hash table versus like a vector to search for things. Huge difference. And also in this class, we went over the standard library a lot, just because you can just do random shuffle and it'll shuffle the vector for you. You don't have to write your own. Sort, don't write your own. Use the standard library most of the time. It's good enough. And so just getting familiar with the standard library and leveraging it, right? So that you spend your time solving interesting, things rather than reinventing the wheel every time. So that's 40 and 41. Next class is 26, which at Fresno State is called 60 for some reason. We copied their numbers for, I don't know, some of their classes. 1, 40, 41 are the same. 26 and 60, same class, just different numbers. And then our 45 is their 110 or something. It's a junior level class, technically, at Fresno State. So if you take CSI 45 here, you actually get credit for a junior level class at Fresno State. At my institution, UC San Diego, CSI 45 was sophomore level. Yeah, I took it as a freshman, but kind of sophomore level class, assembly programming. So discrete math goes over. It's more mathy, hence the name discrete math. It's more mathy than probably any of the other computer science classes you'll take here. I kind of dialed down the math a little bit. I believe in getting students as good at programming as possible, and so there's half the class is programming, half it's math. And the programs you write are the math things. So like if you have to compute shortest paths on paper, you have to write it in code too, so that you really understand it. And you have to do proofs and things like that on pen and paper too. Big O notation plays a big part in CSI 26 as well. Big O never goes away. It's just kind of one of those things you just internalize after a while, right? Time complexity, space complexity. If this algorithm has a linear time complexity, that means it's big O n. And you'll see that in all the references and things like that. It might have constant space complexity or no overhead, or which means it doesn't need any extra RAM. Some algorithms need a lot of extra RAM, like hash tables. Hash tables can consume a lot of RAM because you throw RAM at a problem when you're doing hash tables. And that's just part of being a computer science major. It's like internalizing that lingo. That's a big O in squared algorithm, but if it becomes a problem, I'll turn it into order in, log in if it matters. And you'll just hear people talking, like at a dinner party. Like my friends and I would be sitting around drinking beers and saying I was able to take an order in squared algorithm down to order in. My friends are like, oh, how'd you do that? I'm like, well, the guy who wrote it was repeatedly running over the same computations over and over again, and I discovered that he was just wasting most of the computations, and so I just saved the results of the computations into a table. So I am using more RAM, but the running time went from order in squared to order in, so it runs way, way faster now, at a cost of a couple extra megs of RAM or something. They're like, oh, very good, very good. Then we clink beer glasses together and I do a keg stand or something. I don't know. So, yeah, I mean, that's just what it's like, when you're just socializing with computer science people. And when you go in for a job interview, a lot of job interview questions are to see if you've taken this class and if you've taken 26, right? Like you'll get a lot of questions on data structures. That's the most common job interview question, is like once you get past FizzBuzz and things like that, it's like, all right, write a linked list for us. A friend of mine applied to Facebook and they had him reverse a linked list. So if you have a singly linked list, write a program that will make the tail the head the tail, and all the arrows go backwards. You have 15 minutes, go. That is a extremely common job interview question. Also, CSI 26, very common. Like, if you had to find the shortest path between 2 points, which algorithm would you use? And you'd be like, I don't know, Dijkstra's A-star. If you guys have been getting a good grade in this class, you're probably ready to apply for jobs as a junior developer. I got my first job after 41, and this book here, I'm sure you can find alternatives to it as well. They go over how the different companies interview people, and the interviewing process can be time consuming. So typically these days they'll start off with like a Zoom interview, so you don't have to fly out or anything like that. But if they like you, they take a look at you. They give you some really easy screening questions, like write FizzBuzz in 10 minutes or less, and you guys should practice and be able to knock that out. If they like what they see, then they'll fly you out to Redmond if you're applying for Microsoft. And then you spend a whole day in interviews. And you talk to different technical leads. And they ask you questions. And if they like you, they make a note of it in your file. And then the next person reads it. And it's like, oh, this guy's a total moron. And then they'll write you off. So you have to make a good impression all along the way. And then they'll take you out for barbecue and things like that. Or at least that's what happened. My friend was there. They take you out for barbecue, and the interview continues all day long. You just have to be kind of charming, kind of sociable, because they're evaluating you as a person in addition to your technical skills. And people that are toxic individuals, and they come in all sorts of different flavors, nobody wants to hire them. Right? Like if I was hiring a professor, let's say, here at our school, and a guy walks in and says, you know what I don't like? Millennials. Those guys, man, they're always on their phones. They don't understand what it's like to work hard. They got no discipline, and I don't know if I'm telling a true story or not right now, but let's say it was, that person wouldn't get called back. You know what I mean? Because like here at our college, we want professors that are positive towards students, and care about their learning and stuff like that. So none of that is true. Yeah. This is already making me nervous. The interview. So practice, right? And so the good news is for a junior dev job, the you're not expected to be a that good. I guess is one way of putting it, right? They're not going to teach you how to program. Like mostly what they want to know when you apply for a junior dev job, is do you know the programming language? Like, do you know functions? Can you make a function? Can you make a class? Can you make a hash table? And then you'll be sitting under the wing of a senior dev. A senior dev is somebody who has junior developers working for them, and they'll teach you the ropes. And I was really lucky to have a really good senior developer teaching me while I was on the job. And I'm watching him, and just watching him knock out like these incredibly, to me at least, difficult things, right? Like we were doing virtual reality arcade game programming, and I'm making a heads-up display, and it takes me like a week, and I make a pretty cool heads-up display, but there's no font. Like I don't have any letters on it, right? I have lines and things like that, but I don't have any numbers or words, and that's a problem because you want to display your ammo count and things like that. And so he's like, "Oh, just give me a lunch. Yeah, I'll do it for you. I'll make you a font." What? And so he writes a program during this 45-minute lunch break. He writes a program that reads mouse clicks and draws a line between them. And then he hits a button like A, and it saves it into a file for A, and it just has basically the coordinates of mouse clicks. And then he hits space to clear the screen, and he clicks out the letter B, capital B, B. And he does that for each of the letters, each of the numbers. You need any special characters? I'm like, I don't know, a few maybe, equals. And so he just knocks, and he's eating, I remember this, he has like a pasta salad his wife made him. He's like eating it with one hand and just like clicking out a font and saving it. And he's like, here you go. And he hands me this, I was just like, what just happened? And just watch, like you just learn from the senior dev. So don't be too nervous about it because you'll learn a lot from just watching experienced programmers. That's one of the reasons why I do coding live for you guys instead of just handing you source code, is so you can see the process that I go through so you can emulate it. Another time he made a terrain map generator that would start with a level field, and then it would drip rain on it, and where the rain would hit, the ground would depress down, and if it hit again, it would start eroding, and it formed canyons and valleys, very realistic looking. And he did that. He knocked that out over like a lunch break too. And I'm just sitting there watching like this 3D Grand Canyon sort of organically evolve, and I'm just like, how the hell did you do that? So. I don't know. In IS-50, I did a sand. Do you remember what the name of it was, William? The falling sand one? Physics, maybe? Yeah.
When did we do falling sand?
2 weeks ago in IS-50B. 2 Fridays ago.
Oh, I don't know what you called it.
What did I call it?
I can't remember.
No.
That's easy.
Yeah, and so I did this live in class, and it sort of simulates snowflakes. What's going on with my screen here? Yeah, whatever.
I think it's drawing too slowly or something.
No, I think it's going off the edge of the screen. It's wrapping. I need to pull it in by one. So you can see it simulates snow, and I've got a little ledge here, and so the snow, when it hits, it'll form a snow pile, so it'll slide off randomly, and you can see how there's a little snow shadow here from the ledge here, stuff like that. So I coded that live in class, and it's all part of the fun. So CSI 26 is discrete math, and a lot of interview questions are from discrete math as well. So this book is good. There's also daily coding problem. Yeah, I have this book in my trunk, and back when I would eat in real life, I would pull it out and eat at Batter Up or whatever, and study, look at the questions and look at the solutions, and so this is another good site here. So where can I watch you code that program? If you want to watch me code that would be in the IS50B playlist from 2 weeks ago. Muya, can you find that for him and post it? And then there's cracking the coding interview, and the thing is, like, these companies also read cracking the coding interview, so they're aware that you're aware of, and it gets very meta. But yeah, a lot of it is just being sociable. Just be not like cocky. You want to be confident without being cocky. You want to be nice without being obsequious. You're like, oh wow, that's the smartest thing I've ever heard. No, just be like, oh, that's cool. And like show excitement, and people rate people on their energy, right? If they seem like they're just like tired and like like nobody wants them. They want people that are full of energy and things like that. You want people that are experienced, but you don't have to be a master, because most companies have their own like niche they work in. And so, like, if you've never done business to business coding before, they'll tell you like it'll be a plus if you've done it before. But if you haven't, they'll teach you how business to business works, because it's a different world than like the scientific computing world, which has its own thing going on, right? And so every field has kind of its own norms and expectations and things like that. And if you know it, it's good. If not, don't worry too much about it. Somebody else might get hired because they've done scientific computing before and you haven't, so them's the breaks. But it's not a death knell. It's just when they're hiring a junior developer, they're looking for somebody that knows the basics, so that they don't have to teach you what a for loop is. They don't want to waste time teaching you an if statement, or how to make a function. Like, that's expected, and then they'll be like, all right, let me explain how business to business stuff works. We use XML to send these things around this way, and inventory control works this way, and they'll explain it to you. It's not it's not the end of the world. Okay, so CSI 60 is a lot of math and programming the math solutions and things like that. CSI 45 is assembly programming, where you write lower level code where C++ compiles down into assembly. Muya, how hard would you say assembly programming is to learn?
It's not the worst thing ever, but it definitely makes you wish you were doing high-level programming.
It's a very political way of putting it. Yeah, like you miss things like cout,
It's like, oh, I have to literally write to the standard out buffer myself.
Yeah.
Because I can't just use cout.
Yeah. Or if you want to do a for loop.
Yeah. Like something. Or you have to use GDB to... You can't just see out stuff in the middle of your program. That'll mess up the registers.
Yeah. Yeah, so deal with it. Nah. No, 45 is useful because, like, now what's kind of going on, right, Muya? With the program?
Yeah.
It's
not too bad.
Yeah, it's a really useful class. You understand kind of what's happening. So after 45, then you get into junior level stuff. And you're going to take data structures again. And you're probably going to learn how to write a balanced binary search tree. So like I said, I talked about it in this class, but I'm not going to have you write it. That's a junior level thing. It's sort of annoying, but not too bad. Learning how to do sets. Like if you want to do a set where you can like put things into a set and see if something's in a set and merge sets together and things like that. That's junior level data structures. Operating systems. Like how does an operating system work? An operating system is an interface between hardware and software. Your program talks to the operating system. The operating system says, access denied or access granted. And then it allows you to talk to the hardware or not, depending on what permissions you have. It keeps the different threads running simultaneously, stuff like that. Parallel processing, which is what I was alluding to in this class, is a junior level. It's a junior level topic, and you learn how to do multi-threaded stuff and distribute programs over different computers, different cores, different threads, all that kind of stuff. There's a lot of different ways of doing parallel processing. They're all really important, and parallel processing is the future. Like that's, even though it's an elective at most places, I would say I would absolutely take it, because everything is parallel these days, and you need to. And if you don't, self-taught parallel programmers tend to write code that crashes or hangs and things like that. Is threading a class called networking or OS? So threading is taught in parallel processing, and thank you, Moya. So let's see, CC 160 data programming. No, that's Washington. No. Yeah. So this is the class at UC San Diego. I TA'd this class for years, maybe not years, for a while. Not nearly all of us now have a parallel computer at fingertips. So you learn OpenMP. That was that hashtag pragma thing I showed you once. How to use C++ 11 threads. Yay! So yeah. So that's, you know, what I gave you was sort of a preview of this junior level class. And then operating systems is CSE 120 and 121. UCSD, Principles of Computer Operating Systems. I think it's 2/4 of it. Yeah, there's 2/4 of operating systems at UCSD. And then what was the other question? There's CSE 100, that's data structures, advanced data structures. And then building stuff with Arduino. Nothing at UCSD. Stanford, they do it. At Fresno State, they have their assembly class does the second semester of their assembly class, you do breadboarding and things like that. But at UCSD, the computer science department pawns that off onto the electrical.
I cut my phone.
ACE 50 and 51, I think. That's what it's called. No, not you. Making, breaking, and hacking stuff. There you go. So, yeah, that stuff's more on the electrical engineering side, where you get to make cool stuff like that. So, it's neat. I've sat in on some of their projects, and they have a whole series. Like there's freshman level, sophomore level, junior level, senior level, building and maker and projects classes, and it's cool stuff. I've seen them do cool stuff. So what is a networking class? Networking is networking. I don't remember the thing, but that's a separate class. Mathematical beauty in Rome. That's cool. Building and programming electronic devices. That's cool. So they've added that. That's new. So doing Arduino stuff. That's neat. Cool. Undergraduate seminar, upper division, data structures, algorithms again. So this is all big O stuff. Probability and statistics. Very important. Theory of compute. So this class here and this class here kicked my ass because it's all like math and math analysis and proofs and things like that. I could have done better in it. It didn't kick my ass, but I definitely could have done better in it. Optimization problems, crypto, software engineering is a good class. Learning how to program, like how you test, like the testing thing we did earlier, TDD, that kind of stuff. Test harnesses, yeah, all that kind of stuff. That's a really good class to learn. 2/4 of it. I took it and took grad school software engineering as well. Operating systems, networks. There you go. 123 is networks. So you learn about the 7-layer model of networking and how to do sockets programming and things like that. So, and then there are 2/4 of that as well. Securities, fun. Compiler is not fun. Compilers is not fun. Programming languages is fun. You learn different programming languages. Databases, really important. Web stuff, I've never been interested in. Java. So I'm trying to prep you guys for the upper division, is what I'm doing. So. Make your own CPU in 140 and 141L. That was fun. AI stuff, machine learning, computer vision. We do a bit of that in 45. Parallel computation. That's what I was talking about earlier. And then graphics is also fun. Making graphics engines and things like that. My IS-50B people have been doing a lot of that this semester. It's been heavier on the computer graphics side than normal. Image processing. Some of you guys did some of that in CSI 40, computer graphics, all this kind of stuff. If you're like into computer graphics, there's a bunch of classes you can take on that. Graphics 2, animation, yeah. So, biology, that's all new. Biology, bioinformatics. Yeah. UCSD has a really good bioinformatics program, just using computer science to do like DNA searches and things like that. And then seminars and topics, those are always fun. And yeah, so that's what my college has to offer. And so some of these areas I didn't take anything in. None of the web stuff I was really interested in. Biology stuff I wasn't interested in. And some of the advanced electronic stuff I didn't take. And then databases. I sat in on databases and decided I didn't want to actually sign up for it. Because like I kind of got the concepts, but I didn't want to go through the effort of writing a database, which is tedious and time consuming. So that one I sort of audited. So anyhow, we're a little bit over, but I'm confused picking school. I just go to UCSD. I like UCSD. It's got better weather. Yeah. Yeah. All right. So, do you do a senior project? You can. Yeah, the 190 and 191s. Yeah, I actually did several projects, and some of them I didn't. You don't have to wait to be a senior. Like I did projects as a freshman and sophomore. I think I did a couple of them, and they're always a lot of fun. You learn a lot, and you just work one-on-one with a professor, and you learn stuff like that. You have an interest in game development, you want to take IS-50. Yeah, and I kind of, I kind of offer IS-50 as a, just like if you like computer science and you want to learn 3D and math and game design principles and things like that, it's actually a way for you to just get extra experience as a software person. 50B especially. 58 is pretty light on the programming. It's got some math, but it's pretty light on the programming side of things. 50B, it's pretty heavy on the programming. It does not require any knowledge beyond probably this class. Yeah. Can we do the decoding for Huffman in class to learn about it? I wasn't able to figure out how to start. Yeah, maybe we can talk about that next time. It's not too bad though. Is IS-50A required for 50B? Yeah, it is. Mm-hmm. It won't make sense to you unless you've taken 50A. All right, so that's it for today, guys. We will wrap up the semester on Friday, and best class you've ever taken is 50. Nice. Yeah, it's a fun class. I like teaching it. And you get to play games. I mean, how many professors assign you to play a board game as homework? Yeah. It's always funny to me when students drop. It's like you're making and playing board games. Like, isn't that what you do for fun? I don't know. All right, so that's it for today, guys. We'll wrap it up on Friday, and like I said, I'll get your new homework assignment pushed out and look for the updated competency exams, and that's about it for the semester. So, peace out. Thanks.